What do you think has been the most important thing humanity has developed since its first contact with space? Even though today our main topic is the James Webb Space Telescope, the truth is that this question will never have a single definitive answer. Because in order to explore and observe space in a deeper, more detailed, and more accurate way, every piece of knowledge we gain requires new knowledge. Every experience we acquire demands another experience. And every technological tool we develop needs a more advanced and improved version of itself. For example, the Apollo missions were extremely important and vital for our relationship with the moon. But if humanity had said, "This is enough," stepped back, and completely stopped paying attention to the moon afterward, we would probably have a much more limited scientific understanding today. Progress in space exploration has never been about reaching a single destination. It has always been about continuing the journey. Now, before we move on to the main subject of this video, the James Webb Space Telescope and other missions like it, don't forget to subscribe to our channel, like the video to support future content, and share your thoughts with us in the comments. And now, if you're ready, let's begin our journey with the James Webb Space Telescope. Since the very first day in human history that we looked up at the sky, everyone who has been interested in it has essentially been asking the same questions. What is out there? Are there other living beings besides us? Is there a potentially habitable planet that could become a new home for us? As we mentioned before, questions like these have been a common ground for many people ever since we first turned our face towards space. However, as our knowledge about space increased, as our experiences grew, and as the efficiency of the technological tools we developed to observe it improved, these questions began to branch out and evolve. Instead of simply asking whether there are beings like us somewhere in space, many people now ask whether there is any form of life at all, even at the level of microorganisms. Or rather than asking whether there is a habitable planet somewhere in the depths of space like our own, the question has shifted to whether we could turn a planet into a habitable one. We learn the answers to these questions, or at least get closer to them, thanks to advanced exploration and space missions such as Voyager 1, Voyager 2, and the James Webb Space Telescope. From the stone observatories built in ancient times to the present day, every telescope has promised us the ability to see farther than before. Each one has shown us a new distance we could reach in space. But James Webb was a little different. The mission of this telescope was not to show us what is far away, but to show us the past. The important point here is this: when we look at the universe, we are not seeing what is happening right now, nor are we observing the same moment in time. When we look into space, we are seeing things that have already happened. As you know, light travels through time, and the farther away something is, the older the history it reveals. This is exactly where the true power of the James Webb Space Telescope begins. At the end of the 20th century, the Hubble Space Telescope showed humanity the aesthetic face of the universe: colorful nebulae, striking galaxies, and sights that were previously unimaginable, almost mythical in nature. However, the scientists who designed and used Hubble knew its limitations very well. The first stars and the first galaxies of the universe were not hidden in visible light, but in infrared light. The light emitted after the Big Bang had been stretched as the universe expanded and shifted toward the red end of the spectrum. In other words, a telescope that wanted to see the infancy of the universe needed infrared eyes capable of penetrating dust, gas, and darkness. And this capability would finally become possible thanks to James Webb. This telescope was not designed merely as a large mirror or a powerful camera. It was conceived more like an extremely delicate organism that had to operate in the harsh environment of space, because making infrared observations means not becoming blinded by its own heat. In other words, for the James Webb Space Telescope to observe with the correct values and with the highest possible level of precision, it had to resist even itself. The slightest increase in temperature within the telescope could cause it to confuse its own heat with the signals coming from the universe. For this reason, the main body of the telescope, its very heart, was hidden behind a massive sun shield designed to block the heat coming from the sun, the earth, and the moon. This shield consists of 5 layers, and when fully deployed in space, it reaches the size of a tennis court. Each layer is separated from the others by only a few millimeters, and each one was engineered to operate at a different temperature. The goal was to lower the telescope's operating temperature to below -200 degrees Celsius. The mirror of the James Webb Space Telescope is the largest mirror humanity has ever sent into space. It is composed of 18 separate hexagonal segments and is coated with gold. Gold was chosen because it reflects infrared light with near-perfect efficiency. However, this is also one of the reasons why the total cost of the telescope exceeded $10 billion. Yet this enormous cost never caused scientists to step back, because this telescope is arguably one of the most important tools in human history. Even so, the challenge did not end there. The mirrors on James Webb had to unfold one by one in space and then be aligned with microscopic millimeter-level precision. This made the work of scientists and engineers far more difficult, especially because, as an additional obstacle, no test conducted on Earth could perfectly replicate the conditions of space. In other words, this telescope would prove whether it truly worked correctly for the first time only after it was in space. That reality turned James Webb into one of the riskiest scientific projects ever undertaken, and many engineers and scientists willingly chose to take that risk. James Webb is not a telescope that orbits around Earth. Its home is a cosmic balance point known as Lagrange Point 2, located approximately 1.5 million kilometers away from our planet. At this point, the Sun, the Earth, and the Moon remain almost perfectly aligned in the same direction. This allows the telescope to stay in constant shadow and ensures that its sunshield is always oriented correctly. Just take a moment to appreciate the precision and brilliance behind these calculations and this knowledge. For many people, missions and projects like this may seem simple or insignificant. But as you can see, every single detail is carefully planned down to the finest point. However, I must sadly say that this location comes with a cost, and that cost is the fact that no astronaut can be sent to James Webb. Some of you might wonder why this is such a critical issue. It is important because it means that this telescope cannot be repaired or upgraded like Hubble. In other words, a single serious failure could destroy decades of effort in just a matter of seconds. Fortunately, no such negative situation has occurred so far. When the calendars showed December 25, 2021, and James Webb was launched into space, the scientific community, so to speak, completely held its breath. After launch, in order for the telescope to become fully operational, hundreds of critical deployments and adjustments had to be carried out one after another over the course of nearly a month. This meant that scientists and engineers had to work non-stop for an entire month. Every mechanism was a one-time operation. If even a single component failed to deploy, there would be no chance to fix it. Everything, all the effort, all the research, all the details, all the engineering marvels could have been turned into nothing in just 1 second. The mirrors unfolded, the sunshield was tensioned, the system slowly cooled down, and finally, James Webb captured its first light. Thankfully, everything went exactly as planned. Scientists and engineers continued their work with pride and motivation, fully aware that this moment marked the beginning of a new era in humanity's way of looking at the universe. Scientists and astronomers who began analyzing the data coming from the James Webb Space Telescope were initially quite surprised, because the universe Webb was observing looked very different from the one we were used to. Star-forming regions that had been hidden behind dense clouds of dust became visible for the first time in history. Planetary disks forming around young stars appeared almost like frozen moments in time, laid out before our eyes. But the truly surprising and revolutionary discoveries were happening much farther away. Webb detected galaxies dating back to periods when the universe was only a few 100 million years old. What made this even more astonishing was that these galaxies were far larger and more mature than expected. This indicated that the universe organized itself much faster than we had previously believed. As a result, many scenarios written in cosmology textbooks, numerous theories, and countless predictions had to be reconsidered and debated once again in light of these new observations. Perhaps one of the most exciting capabilities of the James Webb Space Telescope is its ability to analyze the atmospheres of exoplanets. When a planet passes in front of its host star, a small portion of the starlight filters through the planet's atmosphere. James Webb analyzes this light to determine which gases are present in that atmosphere. Molecules associated with life, such as water vapor, carbon dioxide, and methane, have been measured with unprecedented clarity for the first time in the history of space exploration. This is precisely why such importance is placed on this telescope and why its scientific value is considered so high. Thanks to James Webb, for the first time, we have gained such advanced information about the possibility of finding life on planets in other star systems, and even in other galaxies. Of course, James Webb never tells us, there is life on this planet, or there is life in this galaxy. Instead, it reveals where the chemical conditions necessary for life to emerge are more likely to exist. Before Webb's discoveries, many astronomers and scientists believed that the chemical building blocks of life were extremely rare and sparsely distributed throughout the universe. However, these observations showed that such chemicals are not rare at all, but rather quite widespread. Because of this, news about potentially habitable planets and moons has become much more frequent in recent years. Yet a large portion of the general public has realized that these news stories are often misleading or not as exciting as the headlines suggest. When someone sees a headline claiming that a potentially habitable planet has been discovered, they initially feel a surge of excitement and want to dive into the details. But as they look deeper, they often find that only certain chemicals are present, while many other necessary conditions for life are not met. For example, a planet might contain all of these gases but orbit extremely close to its star, or it may not have suitable gravity for life. It might lack a magnetic field altogether. People who associate the emergence of life solely with chemicals or a single condition often feel disappointed when they encounter such news. And of course, many pages and media outlets bear significant responsibility for this, as they frequently use misleading headlines simply to attract more attention and engagement. And this is exactly where James Webb stops being just a telescope for us. It becomes the most serious instrument humanity has ever used in its search for whether we are alone in the universe. Because our questions are no longer theoretical, they are observational. We are no longer simply creating theories or making guesses. Instead, we measure, analyze, and draw conclusions based on real data. Moreover, the importance of telescopes like this is not limited to understanding space alone. The experience and new technologies developed while building and improving these instruments contribute indirectly to many fields on Earth. Ultra-sensitive sensors, advanced thermal insulation systems, data processing algorithms, and AI-assisted analysis methods are just a few examples of areas that continue to advance thanks to these technological developments. Many of these innovations are now used in fields such as medicine, environmental sciences, and engineering. When you look at it this way, the invention of this telescope does not only guide us in observing the universe, but also serves as a compass for our human needs here on Earth. In short, the James Webb Space Telescope is one of the boldest and riskiest investments humanity has ever made. It does not only show us stars and galaxies, it opens a window into the depths of time itself. It allows us to question where we came from, how the universe was shaped, and perhaps whether we are truly alone. It also helps prevent the spread of countless false theories and fabricated stories. In a way, it becomes our eyes, our mind, and our ears in the cosmos. So that's it, my friends. James Webb and all other space-related technologies hold an incredibly important place for us. These instruments no longer shape only our future, they are now shaping our understanding of the past as well. Who knows? Perhaps the past we uncover thanks to these tools will become a guiding light for our future and illuminate the path ahead. That's all from me for today. Now I'm heading back into research mode to find another new, fascinating and valuable topic. Until the next video, don't forget to subscribe to the channel, like the videos, and share your ideas in the comments about what interesting space and universe topics you'd like to see here. Until we meet again in the next video, take good care of yourselves. Goodbye.